All right, let's take a look at a complex circuit with meters. Given the schematic diagram below, determine the reading of both the ammeter and the voltmeter. Well, what I'm going to do to start this off, we've got a couple power supplies here, is just look at this for a minute and see what we can figure out. We'll call this the zero side of our battery, so that's 30 volts. That must be 30 volts here. We've got current flowing. We'll call this I1 flowing through R1. Over here we've got plus 5 volts. Well, I'm going to call this side 0 volts again because it's on the same wire. This must be 5 lower, so that must be negative 5 volts over there. If this is 0, we must have 0 volts over here as well. And we're trying to find the reading of both the ammeter and the voltmeter. All right, let's add I2 for the current flow through there, and we must have I1 flowing through here as well. That would be an I3. So let's see what we have as we apply Kirchoff's voltage law around the loop. And what we're going to do is we're going to start here. As I apply Kirchoff's voltage law, I'm going to see negative 30 first, plus 10 I1, plus 20 I1. Then I see the negative 5 before I get back to where I started, equals 0. Well, I've got one equation and one unknown. This just became relatively simple. What I can do then is a little bit of algebra here and say that I've got 30 I1 must equal 35. Therefore, I1 equals 35 over 30, or about 1.17 amps. I1 is what goes through the ammeter, so there's our first answer. All right, let's try and find the reading on the voltmeter. Well, the voltage drop across this R1 is going to be I1 times R1. So V1 equals I1 times R1. That drop then, I1 1.17 amps times R1, 10 ohms, is going to give us a drop of 11.7 volts. If this side is 30 and we drop 11.7, that must mean we have 18.3 volts left over here. And the voltmeter measures the difference from this point to that point. That's how it's attached. The difference between 18.3 and 0 volts is just 18.3 volts. So the voltmeter reads 18.3 volts. Our second answer. That wasn't nearly as bad as I expected when we first looked at it. All right, let's take a look at one more nice simple problem to round this out. 3 resistors, 4 ohms, 6 ohms, and 8 ohms, are connected in parallel in an electric circuit. The equivalent resistance of the circuit is, well, right away, if they're in parallel, I know that my equivalent resistance must be less than 4 ohms. Oh, wait, there's our answer right there, less than 4 ohms. All of our other choices are larger than 4 ohms. Very little thinking required, just knowing that formula and a couple facts. Hopefully that gets you a great start with circuit analysis. Thanks so much for your time and watching Educator.com. We'll talk to you again soon.